Good evening, student, and good evening to you all. Today, in the data analysis and interpretation class, the focus will be on regression. Very popular word. You hear people say it all the time. So I am going to take you through it. Remember, we are not focusing on the calculation aspect, but rather just the interpretations. I am your instructor, Richard Kofi Aswabo. I am from the Economics Department of the Ghana Communication Technology University. This is my email. When in doubt, you could send me an email and I'll take time to reply. What will be my outline for today? I'll follow the same outline as I'm used to. The only challenge was I use a new data set. And as usual, I do not own the rights to this data, but I have the right to use it for tutorial purposes. Okay, so in regression, there are two main types, linear and simple. In a linear regression, we want to predict the value of any variable based on the value of another variable. Remember, it is singular. One variable as against another variable. The first variable that we want to predict is called the dependent variable, the outcome variable, the target or criterion variable. What a name. And this variable is the variable we want to predict. Then we have the independent variable, the predictor variable, the predictor, the explanatory, or the regressor variable. And this is the variable we are using to predict. If you are focusing on one dependent, one independent, then you have a simple linear regression. But if you are focusing on one dependent variable and two or more independent variables, then we have what we call a multiple linear regression. To conduct a multiple linear regression, you must test some assumption, or your variable must meet certain conditions. One, your dependent variable should be a continuous variable in scale. That is, it is either an interval or a ratio. Number two, you must have what? One or more independent variables. And the variables can be continuous, that is interval or ratio, or it can be categorical, that is ordinal or nominal values. Assumption number three, there must be independence of observation. That is independence of residual. And this can easily be checked in SPSS using what we call the Dapping Varsity, the GW statistics. Very easy to perform. Assumption number four, there must be linearity. Linearity either between the dependent and independent variables individually or collectively. There must be a linear relationship between the dependent and independent variables. The fifth assumption is homoscedasticity. What a beautiful name. Homoscedastic. Implying that the variance along the line of best fit remains similar as we move along. Remember issues about homogeneity. Then number six, there must be multicollinearity. There must not be multicollinearity. A multicollinearity occurs when two or more independent variables are highly correlated. Two or more independent variables are highly correlated, and multicollinearity will usually exist if you are doing what we call the multiple regression. If you are doing the multiple regression, then there must not be significant outlier. Remember, if there is an outlier, your p-value will give you an inaccurate p, and this will negatively influence any policy that is being made out of your results. So, to check for outliers, we use the box and whisker plot. I hope you remember the box and whisker plot. Assumption number 8, the residual or the errors are approximately normally distributed. Remember normality? And to check for normality, you can use histogram. To use the PP plot or the QQ plot. How do you perform regression? 5 basic steps for linear regression. 1. Analyze regression linear. Straight in SPSS. Analyze regression linear. And after clicking on linear, this is what happens. You have your linear model open this way. You select the dependent and your independent variable. In our case, the dependent variable is price. The independent variable is income. And then you check for the 4 of the 8 assumptions. Assumption number 3 of no outlier, independence of observation, homoscedasticity, and normal distribution can be checked. And how do you do that? Using the statistics and then the plot command. After selecting the test you want to conduct, you click on what? The OK button, and it will generate the results. From the data set, the results will generate some output. The key of such output is the model summary. As the word implies, it's a summary. In that table, you will see R square, adjusted R, and the standard error of the estimate. The R in a simple linear regression is your Pearson correlation. And your Pearson correlation value is what? 0.873. That is what? 87.3%, which indicates a high degree of correlation or a strong degree of correlation. Your R square value indicates how much of the total variation in the dependent variable. Remember, our dependent variable is income. Can be explained by the independent variable. Remember, our dependent variable is price. Sorry. How much of price can be explained by the independent variable, which is income. In this case, from our results, 76.2% of the variation in price is explained by income. It means that income explains 76.2% of variation in the model. So let's assume we have another model that has your dependent variable to be test scores. and your independent variable to be age. If if your R square is 76, it means that as your age explains 76.2% of the scores you obtain. I hope that is clear. Now, this is also explained here. So R square, 72.6% of the variation in price will be predicted from the variable income. But it is also important to know that the R square is an overall measure of the strength of association and does not reflect the extent to which any particular independent variable is associated with the dependent variable. In a nutshell, the R square is measuring the overall strength of association, not causality. So the R square measures the overall strength of association between what? The dependent and independent variable, not causality. Again, there is what we call the adjusted R square. The adjusted R square is like an honest friend. It attempts to yield a more honest value of the estimated R square from the population. Remember, our R square is saying is what? 67.2%. But adjusted is saying no. In a normal, honest manner, it is what? 74.9. When we have the Anova, we have already seen an Anova test and what it is used for. Please, if you have forgotten, go back to the Anova video. So the Anova test it reports how well the regression equation fits the data. How well the regression equation fits the data. Whilst the R square is measure of what? Strength of association. Here, the Anova, in this case for our regression, is how well the regression equation fits the data. It indicates that the regression model predicts the dependent variable significantly well from the Anova table. Why? Because our F is huge. Look at our significant value. It's less than what? 0.01 or even 0.05. So less. The C column indicates the statistical significance of the regression model, which is less than this, 0.05, and indicates that overall regression model is statistically significant. And the overall regression model statistically significantly predicts the outcome variable. Once it is significant, then it is a good fit for the data. It means the model is the most appropriate model for the data we have. That is why we use the term it is a good fit for the data. Then, what we are interested in is the table. Remember, we have the unstandardized. That is when the data is kept in its natural form, and we have the standardized when it is standardized. The data is standardized. Now, from this, we can write a regression equation. Remember, to start any regression equation, you must first bring your price, your dependent variable. And in our case, the dependent variable was price. So price is equal to, then you bring the constant term plus the beta terms, the B plus the B, and then your independent variable. So our price is equal to, our constant is 8286.786 plus the B, which is what? And the B is positive. That is why there is a plus here. If the B was negative, this sign would have been a negative sign. Plus 0.564. And what is beside the 0.564 is what? Income. So we put our income there. So the coefficient provides the necessary information to predict price from income. Remember, the regression coefficient is the slope of the regression line. It tells you what the nature of the relationship between the variable is. Remember, the sign will even be a most appropriate because it is positive. Again, if you look at the model, we use the sig value tells you that the model is there from the income section. If you look at the sig value, it tells you the model is significant. And these are the, so if the model is significant, then we can then interpret it. Usually for a non-significant model, there is no need interpreting it because it is not significant. It is just by chance. And remember, we use the unstandardized. The beta of the standardized is usually used if we want to do some element of comparison. So the beta for the standardized is the coefficient you obtain if you standardize all of the variables in the regression, including the dependent and all the independent variables, and run the regression. By standardizing the variable before running the regression, you have put all of the variables in the same scale, and you can compare the magnitude of the coefficient to see which one has more effect. Now, how do you standardize? Sometimes to standardize, you would have to just convert the variables into logarithm. Then you have standardized it. There are other forms of standardization that you can read around. Again, you can also use the t value, remember, to tell whether the model is significant or not. And note, a larger t is more preferred than a smaller t. And for 5%, the t value must be 1.64 or higher. For 5%, the t value must be 1.96 or higher. If it is 1.64, then it is at 10%. So, how is the B calculated? It is calculated by dividing the change in the dependent variable by the change in the independent variable. The difference between the actual value of the y, that's the dependent variable, and the calculated amount is called the residual variable. Remember, going back to the table, we do not have our residual is represented as an error term. So our residual is represented as our error. Now, so the residual represents how much error there is in the prediction of a regression equation for the y value of any individual case as a function of x. The residual represents how much error there is in the prediction of the regression equation for the y value, where the y value is the dependent value of any individual case as a function of the x. The x is the independent variable. In conclusion, how do we interpret the result? You can look at it from an individual interpretation or a general interpretation. For the individual interpretation, you first interpret the correlation coefficient of y, which is 0.873, and indicate that it has a good level of prediction because it is high degree of correlation. Then you interpret the R square, which is also known as the coefficient of determination, which indicates that our independent variable explains 76.2% of the variation in the dependent variable. That is our price. So income explains 76.2% of the variation in prices. And if you want a more honest approach interpretation, you use the adjusted R square, which also means that it is lower. Once it is lower, it means that additional independent variables are not adding value to the model, rather they are decreasing the power. In a nutshell, the adjusted R square is a true reflection of the model. Then you interpret the F ratio in the Anova. Remember, it is significant. So it shows that the independent variable statistically significantly predict the dependent variable. And you can state this as has been stated. Hence, the regression model is a good fit for the data. I repeat, the F ratio shows that the independent variable statistically significantly predicts the dependent variable since it is significant. Hence, we say that the regression model is a good fit for the data. Then we interpret our regression model itself, which shows that for each CD increase in income, there is a 0.563 increase in price. Because remember from the equation, income is positive. So price is equal to 8786 plus 0.563 income. So if income increases by a unit or by a CD, price will increase by 0.563 cedis. In general, you can look at it from this way. Mention the F, mention the R square, then mention a significant p-value. So you can say that from the regression, you run to predict the price from income. The variable statistically significantly predict price. Our F into bracket 118 is equal to 57.737 with a p-value less than 1. R squared is equal to 0.76. Income variable adds significantly to the prediction. You can see that in your rules. Good. And it is correct. But I would prefer you give the individual conclusions. That makes it interesting. That said, for the simple linear regression, what about the multiple regression? The same procedure, 7 steps. Click on Analyze Regression Linear. You have this. You select your variables. So in this case, it is cost, sex, age, alcohol, cigarettes, and exercise. Based on whatever you have, you can also look at selecting some of the statistics. And when you get to statistics, you can select the confidence interval. The model fits. You click on Continue. Then you come to Options. You can select to include a constant in the equation, exclude case-wise list, and then again, you can click on Continue, click on OK, and voila, this is what you get. Remember, our R is in this case, since it's a multiple linear regression, our R is a multiple correlation coefficient. It has the same interpretation. In this case, it is 0.629. So what do we say? We say that the Pearson correlation between the scores is what? 62.9%. Our adjusted R, our R squared, sorry, is 0.395. And simply, the R square is what? The proportion of the variance in the dependent variable accounted for by the entire regression model. It is also known as what? The coefficient of determination. And we'll remember our adjusted R square. Again, how do we write the equation? Remember, our dependent variable is cost is equal to, look at the constant term. It is negative, so we write the whole constant term starting with a negative. Look at that of sex. The sign before it is positive, so that is why it is positive. Look at that of H, for the unstandardized coefficient. It is positive, 114.658. That is why we have the positive sign. Let me go down to average hours of exercise. Look at it. Look at the sign before it. It is negative. Negative 271.277. That is how come we put a negative sign in front there. I hope you understand how regression equation is written. You pick the sign and then you will write the model definition. For example, in the equation, look at sex is what? 509.271. So you write, and the sign is positive. So we start with positive 509. To one decimal place, 0.3. But what does it stand for? It stands for sex, so we pick our sex there. Again, let's look at the last one. It is negative. Negative 271.270. So one decimal place, negative 271.3. Look at what is it standing for. It is what? Average hours of exercise. So we can put the word exercise. Remember, it is the cost of visiting the doctor against all these variables. That's why the dependent variable is what? Cost. How do you interpret it? So, to interpret it, let's take the first one. If we are looking at age, you say that age was measured in what? From our regression, age is measured in years, if you can see. So, we interpret it by saying that a 1 year increase in age. Why increase? Because age has a positive sign. Age has a positive sign. That's why we say it is what? A 1 year increase in age results in an average of what? 114.7 increase in the cost of going to the hospital. This makes sense because the older you become, the more likely you visit the hospital often compared to a younger person. Again, let's look at exercise. Our exercise value is negative. Negative what? 271.270. But what is it? It's an exercise, average hours of exercise per week. So how do we interpret it? We say that the 1 hour, because exercise was measured in hours, increase in exercise per week is associated with, what was the sign? A negative. So was associated with what? A negative 271.3 increase. Once you bring the negative, you can use the word increase. But if you don't bring the negative, then you would then say a 1 hour increase in exercise per week is associated with a 271.3 increase in yearly health cost. Decrease in yearly health cost. Remember, the sign was negative. That is how come we use the word decrease. And it is true. If you exercise more, the tendency of going to see your doctor decreases. So you are able to save more when you exercise more. Similar results are there for your interpretation. I would want to end here, but please go through the slides. Very interesting things to interpret. And please take your time and go through. Remember, we are interested in interpreting significant values. So you must look at the 6 before you interpret. One more interpretation before I close. Let's look at alcohol consumption. Look at the coefficient. Is what? I know you have said it is positive. It is positive. So, again, it is significant. So, how do we interpret it? We say the consumption, a 1 unit increase in the consumption of beer per week is associated with what? A 50.83 increase in the cost of medical health care, implying as you consume more alcohol, the tendency of you going to see the doctor for you to incur costs increases. Ladies and gentlemen, I will thus bring us to the end. In short, what is regression? It is used to predict the relationship between one variable and another. One of the variables is known as the dependent and the other is independent. If there is only one dependent, one independent, we say it is a simple linear regression. If it is one dependent, several independent, then we say it is a multiple regression. Remember the 8 assumptions that must be taken into consideration and what tests must be carried out. Also, remember the SPSS procedure and remember how to interpret the results. Interpret your F values, interpret your R values, interpret your adjusted R, interpret your R square, and then come back to the coefficient model and interpret it. Before I forget, how do we conduct it in SPSS? So I open my health model, click on Analyze, look for regression, look for linear, there you are, click on OK. Then what were we interested in? Cost, so dependent, we had sex, we had age, average consumption, alcohol, average consumption of cigarettes, and exercise. We select all of them. What would be our statistics? We want the model, we want the confidence interval. We can even test the linearity, and this is the model for multiple linearity test. We can check it. Remember that they've been wasting for residual. Click on continue. Again, you can come to plot if you want. I'm not going to really worry my head about the plot. Remember the normality plot, the histogram, and then if you want to perform any other QQ plot. Our options, again, we can use F value if we want to. If we don't want, we can ignore it. So let's click on continue and we click on OK. And there you are. Everything as programmed by the model as seen in the lecture notes. And remember, these are the 3 models. Remember the first model, model summary. Our R, the correlation is 62.9. Our R square is what the coefficient of determination is 39.5. Our model summary, our F from the Anova is statistically significant. It means it is a good fit. Then we come and interpret a coefficient. On that note, ladies and gentlemen, close here, and please do not hesitate if there are areas you want me to draw much on. Send me an email and I will gladly respond. Have a good evening, and God willing, we'll meet virtual in the next life. Bye bye.